So very good afternoon to all. In this third lecture, we will be discussing about nanotechnology based formulation. So for studying nanotechnology based formulation, we must know what is the nanotechnology first. Okay, then only we will be able to understand what is nanotechnology based formulation. So in this particular class, we will be discussing about nanoscience and nanotechnology. Then we'll be having a brief discussion on nanomaterials. Then we'll discuss a few points about the classification. Just to understand what are nanomaterial, we'll discuss about brief classification. Then we'll discuss mainly the application. Okay. So just have a next slide. Nanoscience is basically the study of nano material, or we can say the materials which are in nanoscale level. When we study them, we call it a nanoscience. Science is a study of nanomaterials or nanoparticles or nano things. We call it nanoscience. So nanoscience is a study of structure and material on an ultra small level, that is nano. Then nanotechnology. Nanotechnology is the fabrication of nanomaterials. Basically we can say it is a fabrication of nanomaterials. Fabrication means we can first we can design them, synthesize them, then through the scale up process we can produce them in a larger quantity if they are beneficial to us. Okay, so all these techniques, whatever we study for the synthesis, for the production, all this we study under the nanotechnology. So nanotechnology is the design, production and application of structures, then device and systems at the nanoscale. Then because of the tremendous application, that is because of tremendous potentials in the nano materials, the attraction of these material has been seen in a wide range. That is, none of the field has been untouched by this technology. That is, in every field we are using nanotechnology. Say in paint industry, textile industry, in the food industry, agriculture industry, then various industries, the nanotechnology has been used. Okay, that's why nowadays everybody is want to know about the nanoscience, nanotechnology. Why? Because we want to have innovation. Actually, every field it needs innovation. Why? Because we want the best thing. We want to do the best in a particular field. So, if we want to do best in a particular field, we have to study new techniques. So, this is, we can say, a nanotechnology is a new branch of science that deals with nanomaterials. So, nanoscience is the study of nanomaterial, whereas nanotechnology is the creation of nanomaterials. And after creation, that is, if we want to confirm whether the nanomaterial has been formed or not, as such they are very small, they cannot be seen by naked eyes. So for that we need a very advanced techniques. So whatever we study, that is how to characterize them, how to observe them, whether they are formed, whether they are uniformly formed or not. So several techniques are there. So all these techniques we study under the nanosciences. Okay, so characterization and the study we do in the nanosciences, whereas the creation, formulation, fabrication, they come under the technology. Okay, so please. So on this slide showing the creator of this particular term, we can say the concept of nanotechnology was basically given by a physicist, that is Richard Feynman. Please have a next slide. So in this we'll discuss about how small is nanomaterial. So, as such, nanomaterials, they are of nano size. Now, what is nano size? We all know that nano means 10 to the power minus 9 is the nano size. So, we all have studied about the microorganisms. Microorganisms, they are in the micron size. All the bacteria, then your yeast, even though we cannot see the micro world also, why? Because our resolution power of eye is not that we can just see objects which are within millimeter range, or we can say up to the particular more than some less than the millimeter, but not the micron range. So for that we use microscope, compound microscope. That is, if we want to observe micron particles which are of micron size, we need microscope. Now even here also, as the nano size is still smaller than the micron, that's why we need a more advanced equipments or instruments just to observe the nano materials. So this is a particular slide through which we can just compare the things. Like in the left hand side, the image is showing the scale and the articles of the size of the articles. Like a baseball bat is near about 1 meter long. If we say compare the other articles like coin, it is near about in the centimeters, and like the thickness of hair, it is in the micron size. Then the size of bacteria, it is again the micron size. Now if we talk about the size of DNA strain, the DNA strands, they are in nanometers. The size of virus, it is in the nanometer. So then the size of atom, it is in nanometer, even the angstrom. Okay, so this is how we can classify the things. Okay, then in another slide I have shown you the different type. Again, I have shown the things like you can see in the tennis ball is there, and the biggest thing is tennis ball, whereas the smallest thing is molecule of water. In this figure you can see. So what is happening? The scale is nanometer. Okay. So if we talk about the size of tennis ball, it is near about 10 to the power 8 nanometer. Whereas the size of water molecule is 10 to say 1/10 of the nanometer. Okay, that is angstrom, in the angstrom range. That is, here we are just comparing the articles with different on the basis of the size. So now what are nanomaterials? We want to know. Okay, before when we want to study the formulation, the drug delivery system which are at the nano range. So before that we must know what is the range for the nano formulation. So basically all the materials which lies between 10 to 100 nanometer, they are considered to be as a nano materials. Okay, so the material which are having a size in about 10 to 100 nanometer, those are nano materials. Okay, now in this figure also you can see from 10 to 100 nanometer, what you can see is, you can see the size of antibodies, the size of virus, they lie in the same range. Then the nano devices like your dendrimers, nanotubes, quantum dots, nanotubes, all these, they are within that limit. Okay, whereas the size of glucose is below than this, size of bacteria is more than this. Like the size of bacteria is 1000 times, or we can say 1000 nanometer. Clear? So this is just I have shown you a comparison of size with the other thing, the smaller range as well as the bigger range. So I think this much is clear to all of you. So just give me a next slide. Now again, this slide is also showing again about the nanotechnology. So nanotechnology basically it involves the control of matter at the atomic level. That is when we work on atoms. That is when we want to formulate any nano formulation. What we have to do is we have to work on the atomic level. Okay. Then so atoms, they are considered to be as a building block material for the nano formulation. Okay. Then so size of nanomaterial is 10 to the power minus 9. That is 1 billionth of the meter. Okay. So 1 nanometer is 1 billionth of your meter. Then comes the what is nanostructure. So nanostructure, what is nanostructure? All the structures on a material which lies between 10 to 100 nanometer, both are nanostructures or nanomaterials. Both the terms they are being used, nanomaterial or nanostructure. Now again one thing comes like whatever the matters which exist, actually the matter can exist in say three-dimensional structure, we can say. Like every object, they have 3 dimensions. One is x-axis, y-axis and z-axis. Okay. Like if we say about the say rod. Okay. So x, y and z, 3 axes are there. So all the matters, they have 3 dimensions. Okay. So if a matter is having at least one in the nano range, then that particular object will be considered as a nanomaterial. Like for example, if we are having any surface and if we put a nano coating on that, then also it will be considered as a nanomaterial. Okay, that is it does not depends on the object, the property of the object, but it depends on the say like coating. If it is having a nano coating, it is an application of nanomaterials. Got it? Next. So again, I have just given some comparison between the different articles. Let's see. The strain of DNA, it is about 2.5 nanometer in width. Then your RBC is about 7,000 nanometer in width. Then sheet of paper is 75,000 nanometer. Then hairs, the thickness of hair is near about 50,000 nanometer. And if we talk about hydrogen atom, if we assemble hydrogen atom side by side, say up to 10, they will gather in the distance of 7 nanometer. So this is again a comparison of sizes. Okay. Next slide please. So again, what are nanometers? So nanomaterials are defined as set of substance where at least one dimension is less than 100 mm. This is very, very important. That is, set of materials which are having at least one dimension below 100 mm is nanometer. Got it? So actually the scientists, they have studied that nanomaterials, they have unique properties. Unique properties, they have optical unique properties, electrical, magnetic and other properties. Because of this, the attraction towards these materials are so much. Why? Because they have unique property. Like for example, if we consider the gold, like if we take a lump of gold, it is very shining lump. But say if we convert them in the nanomaterial, the properties will definitely they will change. There will be dramatic change in them. That we will be discussing in the further slides. So next. So the same slide. What are nanomaterials? Okay. So actually they are super tiny materials. You can say nanomaterials, they are super tiny materials. So again we'll discuss about the classification. Next is classification. So now basically they are classified into 4 categories. The first one is 0 dimension, second one is 1 dimension, third one is 2 dimension, and the last one is 2 dimension. Okay. So like in 0 dimension, all the dimensions are at nano level. Those are called 0 dimension. Okay. For example, nanoparticles. Okay. Nanoparticles, when all the dimensions they are in nano, they are called. Then when the 2 dimensions they are in nanoscale, we consider them as a 1 dimensional. So example is rods, nano wires, nano fibers, nano rods. Okay. So nanotubes. And 2 dimensions, when 1 dimension is at nanoscale, like film coating, that is nano coating that we were talking about. Got it? And when none of the dimension is in nanoscale, then they are called the 3rd dimension, 3D. Okay? So bulk materials, they come under the 4th category. Okay? So please next slide. Now again I have shown you the classification. So 0 dimension, spheres and clusters. Then nanorods, they are under 1 dimension. Then nanofilms in 2 dimension, and nanoparticles. Here it is written nanoparticles, but the bulk materials they come under this. Okay. Next slide please. So nanostructure, we will discuss few of the nanostructures like nanoparticles. Next, fullerene, basically they are called monkey balls also. Next, quantum dots. Next, then there are various other like nanowires, dendrimers. They are highly branched structures. Okay. Next, now we'll discuss about the properties. Basically, what are the attractive properties which the nanomaterial they are having. Okay. So first and very important property is they have a volume to the surface ratio is very high. Volume to the surface area ratio is very high. Now in the slide also I have shown the difference. Like you can see a 10 centimeter cube and a 2 centimeter cube. Okay. Now the surface area of 2 centimeter cube is about 24 centimeter square, whereas the surface area of 10 centimeter cube is 600 centimeter square. Okay. Now if we compare the surface area with the volume, what you can see is the ratio of this is more in case of small cube. The ratio is 3:1 in case of 2 centimeter square, whereas 2 centimeter cube, whereas this ratio is very less in case of larger cube. That is 0.6:1. Okay, so surface area, volume to the surface area ratio, sometimes it's very important. Like wherever the surface activities they are required, like for example, like in case of our field, the pharmacy field, when we are talking about the drugs which are having a low solubility. Now the solution for the low solubility is nano suspension. Why? Because we are increasing the surface area by preparing a nano suspension. When more is the surface area, more will be the surface phenomena. that is dissolution. Dissolution is a surface phenomena. That is when the drug is having a problem issue like bioavailability. Just to overcome this issue, bioavailability, what we do? We improve the surface area by preparing a nano suspension. So this is very helpful in improving the bioavailability of many poorly soluble drugs. Okay, next. So here I have shown about the gold particles. Okay, so we all know that gold lump is about yellow or golden and shining lump. Okay, if we reduce the particle size of gold between 10 to 1000, 10 to 100 nanometer, what we can see is this. In this, you can see in the tubes gold nano rods. What you can see, a variety of colors are there. That means nanoparticles, when we prepare the gold nanoparticles, they give color coloration. And color depends on the particle size. That means now the properties, they are different. What you can see is physical properties have changed. Even the chemical properties, they change. So what they have seen is at nano level, the things or the properties, they changes. And nanoscience changed the things. The gold, basically we are talking about the gold. Say gold property, there is a dramatic change in the properties of gold when we are studying at the nano level. Okay. So basically gold nanoparticles, they are used for catalytic purpose. So the catalytic property is enhanced. Why? Because more is the surface area. More will be the catalytic property. Next, again the physical property. So physical properties also, they are unique. So like magnetic, electrical, optical, all these properties, they dramatically, they changes at the nano scale. Next. So now we will discuss about the application. First we are talking about the application. Further in the next lecture I will be incorporating all the nano formulation. This class I have just taken all the introductory class about the nanotechnology. So in this we will discuss application. So nanotechnology is being used in diverse fields like textile, then biotechnology field, then in cosmetic and paints, agriculture and food industries, in biomedical field. I think you must be knowing few of the example of in this field what are the use of nanotechnology. Still we will discussing in this class. Okay. Then in the field of engineering, in the preparation of microchip for the computer, just to improve the say storage and memory of the computer, these nano chips, they are being used. Then comes basically these are the applications in the electronic field. Then in case of metallurgy and material science, actually we can say the material science is the basic science where this particular stream is applicable. I think material science, we study about the material, and even the vast aspect of nanotechnology is there in that case. So next is in the defense and the security, that is sensing instruments, they can be prepared for the defense purpose. Okay. And energy storage. Now energy storage is also a very important field, because we all know that energy source, still the sun is the main energy source. So efforts they are being done just to store this solar energy and convert them into some very useful, reusable type of form. So basically again lot of research is going on how to convert this solar energy and how to use this solar energy for the for the human being. Okay, so The next please show the next slide. So we'll discuss these application in some more detail. Again, this is also showing the few of the applications of nanotechnology in catalysis, like catalysis is surface phenomena. So there's a this is one of the important application. Then comes paper technology. We use photographic paper. Nanotechnology is used for making photographic paper. Then for filters like nanofiltration, we use nanofibers. So nanofiltration can be used for the purification purpose. Then for dialysis purpose in the biomedical application, dialysis is done by the nanofiltration. Then in food industry, there are various applications like packaging of food, okay, then storage of food, then sometimes packaging with the antibacterial action, we need to preserve that food. Then still we will discuss them in more detail. Please go to the next slide. So in this slide I have shown the application of surface coating. Now the application of surface coating is for preparing easy to clean and self-cleaning windows. That is actually the nano coating is done on the glass or the ceramic surfaces. Now in this diagram also you can see I have shown the two type of surfaces. One is uncoated and the other one is the coated one. That is the surface is having a nano coating. Okay. So what is the difference? You can see when the dust particle, when they comes in contact with the uncoated surface, they get entrapped between the gravings or say pores of the uncoated surface. Whereas in case of coated one, they will just be reflected. So nano coating helps in providing a self-cleaning or your easy to clean surfaces. So windows, the window glasses, they are being prepared by using this type of coating. Then sometimes your cutlery sets, they are being ceramic. That is nano coated ceramics, they are available. Okay. So nano ceramic particles, they give smooth coating. So they provide smoothness, heat resistant, all these. Okay, so this is one of the application. Next please. Now in the textile industry, the use of nanotechnology is for making a water repellent clothes, then your stain proof clothes, then your wrinkle proof clothes. So actually this is a very important application. Now you must have seen the dusters which are coming in the market, which is basically made by the nano material. So they are very easy to clean and okay. So these are the new innovation in the textile field. Next please. So this is the example of application of microchip which are used in computer just to improve the storage of computer, just to improve the memory of the computer, and even nanotechnology is used just to make a more compact this computer. Okay, next. Next is in case of textile industries, generally antibacterial, just to attain antibacterial effect, nanoparticles, silver nanoparticles can be incorporated into the cloth to get an antibacterial effect on the fabric. Okay, so basically, just move to the next slide. The barrier textile. What is barrier textile? Barrier textile is the textile which resists the two-way protection. Neither the thing can go inside nor the thing can come outside. So usually the barrier textile is used in hospitals just to prevent the this thing. So basically in the hospitals the barrier textiles are used. Next. In the food sector, basically food processing, these nanoparticles they are used. food packaging, food safety, then improve the shelf life of food material, packed food materials. Now next is the, since as we know that the particles, nanoparticles, they are very small. So what happens sometimes, the nutraceuticals, if we want to administer nutraceuticals and improve the effectiveness of nutraceuticals, that, like we can say the absorption of nutraceutical, if we want to improve the nutraceutical absorption of nutraceutical, we can use this. So this nanotechnology is used just to improve the absorption of nutraceuticals, and sometimes they are used for antimicrobial agents also. Okay, so these are the applications. Just move to the next slide. So offer improved taste. Nanotechnology will offer improved taste, texture and consistency to the food. Then improve the absorption of the different things. Like this has been tested on the cell lines, in the cell culture, absorption or the intake of various nutraceutical has been improved. So that's why it has been tested that the particle size, it affects the rate of the absorption. Next. So in the agriculture field also, it increase the agriculture production. Now how it can increase the agriculture production is through the application of agrochemicals or pesticides, like fertilizers and all that. Okay, so these are the applications. We can sense the plant disease, we can diagnose them with the use of nano devices, nano sensors. Okay, we can use genetic engineering through nanotechnology. So all these, they are the different ways which are used. Okay, next is nanomedicines. This is very important. As per we are concerned, we belong to the same class, so we will be discussing this part in much detail in the further class also. So basically, nanomedicine is the medical application of nanotechnology, or we can say application of nanotechnology in the field of medicine. This is your nanomedicines, we can say. So I think you must have studied about the various challenges which are being faced when we are formulating any particular dosage form, and through this nanotechnology we can overcome various challenges. Okay, so first one is like the most important one is controlled drug delivery system. Like what are controlled drug delivery system? Controlled drug delivery systems are the systems which can control the release of drug. Okay, now we can use nano carriers for controlled drug delivery system. Now how this nano carrier can help us? Nano carriers, they can help us in the way they can reach to the particular target. Why? Because they have more accessibility as compared to the other particles. Why? Because of the small size. So just to improve the accessibility to the target organ, we can improve this thing. The drug effectiveness we can improve. This is the first thing. Then second one is targeted drug delivery system. You must have studied about that. The targeted drug delivery systems are the system which release drug at the target site. So nanotechnology, again, they help. How they help? We use carriers, nano carriers. Nano carriers, they can provide you controlled drug delivery system, they can provide you targeted drug delivery system. Now, what is the difference between these two? Like, if we are using only the nano carriers, we will consider it as a controlled drug delivery system. But if we are attaching some targeting moiety or directing moiety, then they becomes the target. That is, if foaming device, they are also called as foaming device. So whenever on the nano carriers, if we attach some directing body, those are also called as ligands. So then they are called as targeted. So I think you must have studied various advantages of controlled drug delivery system as well as targeted drug delivery system. So same will be considered here also in the nanomedicines. Like what we can do is we can improve the bioavailability, we can improve the targetability of the drug to specific organ, especially say which are difficult to target. Okay, is the time? Okay. So the organs like brain, it is difficult to target. But here again, nanotechnology can help us. How it can help us? Like when we administer a drug into the body, there are different routes. They can be invasive, they can be non-invasive. So invasive routes, they do not show patient compliance. So again we go for non-invasive. Again, the problem with the non-invasive is drug has to cross several biological barriers. Now, to cross the several biological barriers, what is the need? The carrier must cross various biological barriers. If that carrier is able to cross the various biological barriers, then what will happen? It will easily reach to the target. Okay, so the advantage of nano carriers is the main thing. It can cross the biological barrier. They are readily accessible to the particular organ. Got it? So these are the advantages. That's why nowadays, as a drug delivery system, nano materials, they are being used in various purposes. So next, please. So first, I have shown you the cosmetic, application of nanomaterial in the cosmetics. So what you can see is there are various nano carriers like liposomes, niosomes, polymersomes, solid lipid nanoparticles, nanostructures, lipid carriers, nanoemulsions, gold nanoparticles, nanospheres, dendrimers, all that. All these, what are these? These are all nano carriers. Now these nano carriers can be used either just to deliver cosmeceuticals or the drug molecules, API. Okay, both they can be delivered through these nano carriers. So like the purpose of using nano carriers can vary. It depends what you want to deliver and how you want to deliver. Like for example, if you want to deliver any drug through skin for cosmetic purpose, we'll go for niosomes. Why? Because niosomes, they are easily be taken through the skin. If you want to administer a drug into the systemic circulation, we'll go for your liposomes or niosomes. We can use. So depending upon the purpose, we can select the nanocarrier. Next, please. Again, you must have be knowing about the sunscreens. Okay, in the coming days we will be using sunscreen just to protect our skin against the sun rays, UV radiation. So sunscreens, they are used. Now previously we used to use titanium dioxide particles, macro particles. Okay, why I am saying macro particles? Why? Because the size was bigger. So because of this, they were opaque in nature. Whenever we apply the sunscreen, it used to be visible on our skin. Okay, but nowadays, just because of the innovation of nanotechnology, now what we can do is we can use nanoparticles. Now nanoparticles, the advantage of sunscreen in the nanoparticle is that it will be transparent, it will not be opaque. So even if you are using sunscreen, it will not be visible. Whether you have applied or not, it will not be visible on your skin. But it will solve the purpose of protecting your skin against sun. Got it? So this is one of the advantage of nanotechnology. Next, please. Now this is very important slide. That is in the field of biomedical imaging. Now what is imaging? Biomedical imaging, why it is required? See, there are few of the very chronic disorders like cancer. Like if we want to detect cancer at the early stage, then what we need is we need a very advanced techniques. Okay, so usually X-rays, then your CT, MRI, all these PET, all these they are the basic techniques through which the usually bioimaging is done. Okay, the drawback is what we need is we need a contrasting agent, and that contrasting agent must be reachable, accessible to the finer region. Okay, अब हम यदि बात करते हैं previous era की, before nanotechnology, was what was the problem? The problem was the contrasting agent was not easily accessible to the minute, or we can say the very small level. But today, what we have nanoparticles. These nanoparticles, they will act as a contrast agent. They are easily reachable to the different tissues. You must have heard about the. Just go to the next slide. EPR. EPR stands for your enhanced permeation and retention. So actually the nanoparticles, they show enhanced permeation and retention by the tumor site. So tumor site, actually they have leaky vasculature. Leaky vasculature means the pores, they are there at the capillary region. So these particles, they easily go to the tumor site. So what we can do is we can use this particular physiology for the detection of early detection of cancer. So what we are doing, we are using nanoparticle as a contrasting agent. When we are administering these nanoparticles, they will reach to the cancer tumor site, and through the techniques we can easily, through MRI, PET and all that, we can detect the cancer at very early stage. So this is again a very important application. So I am just stopping here today. We will continue this discussion in the next class. Thank you so much.
Thank you.